Hi class. In this lecture here, we're going to start talking about graphs of the other trigonometric functions. And so if you think about it, in the previous two lectures, we've talked about how you graph sine and cosine. And so now we got to work through the other four. Okay, so we got to work through tangent, cotangent, cosecant, and secant graphs. All right, so this lecture here is just going to be about the tangent function. So what we're going to do here, we just have two objectives we're going to work through. First thing we're going to do is we're going to understand real basic graph of what the graph of what y is equal to tangent to x looks like, just real basic. And then just like I did in the other lectures, I'm going to talk to you about how you graph variations of the y is equal to tangent of x graph. All right, so let's just start with the basics. Suppose I ask you, okay, let's sketch the graph of y is equal to tangent of x so now notice this is important here. Negative pi over 2 is less than x less than pi over 2. So it's a strict inequality here, not less than or equal to. I'm going to talk about that and you'll see why. So I just want to graph it from, this is basically what's going on. Here's negative pi over 2 to pi over 2. So this is what I want to graph it on related to the unit circle. Okay, so what we're going to do this is we're going to get some test points, okay, and we're going to look at those, and then we're going to talk about what the graph might look like from those test points. And so to be able to graph tangent, okay, you got to recall a trigonometric identity. So tangent of x is the same thing as it was a quotient identity here. Tangent of x is the same thing as sine of x divided by cosine of x. So remember that. Okay, so here's what we're going to do, all right, for some test values, okay? So I'm going to pick x, and I'm going to plug it into y is equal to tangent of x, but tangent of x, to help me graph it using the unit circle, remember tangent of x is just sine of x divided by cosine of x. So even though I want to graph, strictly greater than negative pi over 2, let me just talk about what happens if we were to pick negative pi over 2, okay? And then what I'm going to do is I'm going to pick, I want to pick a point between negative pi over 2 and pi. So I'm going to pick negative pi over 4. I'll pick 0. And then obviously I'll pick pi over 4. And then I'll pick pi over 2. Okay, so watch what happens here. Okay, so negative pi over 2 is down here. All right, so it's sine divided by cosine. So what happens here is y is equal to tangent of negative pi over 2. Well, what is sine at negative pi over 2? Okay. So sine is the y coordinate here, so that's -1, and cosine is 0. Okay, so you get undefined here. Okay, so we've talked about this, or we've talked about this in other or you might have talked about this in your other algebra courses here. When you get a divide by 0 here, okay, with something non indeterminate form, so something like a number over 0, what you're butting up here against is a vertical asymptote. Okay, so this value is undefined, but we know it's going to be a vertical asymptote. Okay, so I'm going to, I'll just sketch the graph over here so you can see it. I'll start putting things down. So we have negative pi over 4. We have negative pi over 2. We're going to see what happens at pi over 4. And we're going to see what happens at pi over 2. And so this is what I'm saying. First off, I know right off the bat, boom, 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 vertical asymptote. Okay, so however I sketch the graph, it's going to have to bump up against this. So let's see what negative tangent, tangent of negative pi over 4 is. Well, look, that's here, okay? This is negative pi over 4 right here, okay? So that's going to be sine over cosine. So it's negative the square root of 2 divided by positive the square root of 2. Well, that's just going to be -1. So my next test point is negative pi over 4, comma negative 1. So that would be here. Let's see what tangent of 0 is. Well, remember, okay, so it's sine over cosine. So that's 0 divided by 1. So that's 0. So my next test point, it goes through the origin. Tangent of pi over 4. Well, that's sine over cosine. So that here's pi over 4. So that's square root of 2 over 2 divided by square root of 2 over 2. So that's just 1. So it's pi over 4 comma 1. And then you're going to notice, you're going to get a weird thing here. Y is equal to tangent of pi over 2. So here's pi over 2, right? So that's sine divided by cosine. So that's 1 divided by 0. So again, it's undefined. And we have a vertical asymptote here. So the way you're going to have to draw this, right, to have it go through the points and butt up against the vertical asymptotes is actually going to look like this. You're going to draw a nice smooth curve to it like this. And this is what one period, so one iteration of the tangent graph looks like. Okay, so this is important because it's sine of x divided by cosine of x, right? So what's going to happen is whenever cosine of x is going to be equal to 0, okay? So that's pi over 2, 3 pi over 2, let's get 5 pi over 2, 7 pi over 2, negative pi over 2, negative 3 pi over 2. You're always going to have these vertical asymptotes. All right, so on the next slide here, I got a little bit more of a smoother graph here that you can see, with more test points so that you can for sure see that it blows up, going to infinity there. But here's some important things. The period of the tangent function is just pi. Okay, so note that cosine and sine, the period was 2 pi. Here it's just pi. Okay, that's important. Tangent function is an odd function, so if you have tangent of negative x, that's equal to negative tangent of x. And this is where you're going to have the vertical asymptotes. The tangent function is undefined at odd multiples of x is equal to pi over 2. So that would be 1 pi over 2, 3 pi's over 2, 5 pi's over 2, 7 pi's over 2, and then the corresponding negatives. Okay? And look, here's what this is going to look like repeatedly. Okay, so you could see, we've just done this graph right here, but the graph is going to be periodic, so it's going to repeat itself. And look, you can grab your graphing calculator here, and you can verify this. You can see your graphing calculator shows you that as well. Okay, so you can see the vertical asymptotes in the graphing calculator. Boom, 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 boom. All right, so that's just the basic one, okay? The basic one. So what I want to show you now, okay, is how you're going to graph, variations of this. Okay, so we're going to, put a value in front. We'll talk about phase shifts, the whole deal. I'm going to do 3 examples, and it's going to seem weird. It will seem weird at first how this is done. Okay, it's going to be a little bit different than the sine and cosine lectures, but after you see me do the first one, hopefully it's going to kind of click into place for you. Okay. All right, so here are the characteristics of it that we're going to use to help us sketch the graph. Okay, so we're going to have these vertical asymptotes at these odd multiples of pi over 2. Okay. An x-intercept occurs, this is important, the x-intercept occurs midway between each pair of consecutive asymptotes. So like going back, like when I sketched this, the midpoint between negative pi over 2 and pi over 2 is 0, and that's going to be the x-intercept. Always, always, always. So basically what you're hinting at here is you're going to find two asymptotes, and then the middle of that, boom, x-intercept. All right, now the points on the graph, 1/4 and 3/4 of the way between consecutive asymptotes have coordinates of -1 and 1 respectively. So what do I mean by this? So here's an asymptote, here's an asymptote. This right here is 1/4 of the way, -1. This value over here is 3/4 of the way from here to here, okay? And this has a value of 1. So here's how you're going to be graphing this. You're going to find the two asymptotes. You're going to find the midpoint. This is the midpoint between these 2 points. That's going to be -1. And then the midpoint between this intercept and this asymptote, that's going to be 1. Always, always, always. Okay? And it might seem a little confusing at first, but once you see me do the first one, okay, I promise you it's not too bad. All right, so here's the method we're always going to do. Okay, so this is graphing y is equal to a times tangent of bx minus c, and this is it's all one. I'm not going to do amplitude, then messing with the period, and then messing with the phase shift. It's all just thrown in together. Okay. So here's what we're going to do. The first thing you're going to do is you're going to find two consecutive asymptotes by finding the interval containing one period. Okay, so all this stuff inside here, this moves the asymptotes around. Okay, so what we're going to do is we're going to take the first two asymptotes, -π/2 and π/2, and we're going to solve this inequality here for x. Okay. All right, you're just going to get x by itself, okay? And then what you're going to notice then, okay, is when you solve this, okay, solve this inequality, you're going to have two you're going to find the first two asymptotes, okay? So you can solve them as you'll see how I do it. I do it a little bit different than it's written here. They write two different equations. I'm just going to solve this so I get x in the middle. After you do that, whatever values you have here and here, okay, those are going to be your new asymptotes. And then what's going to happen then? After you do that, you're going to identify the x-intercept midway between the consecutive asymptotes. That'll be, for the problems I do, that'll be pretty straightforward to identify. Then you're going to find the points on the graph 1/4 and 3/4 of the way between the consecutive asymptotes. Okay, these points have y coordinates of -a. This is where the a comes into place, and a respectively. All right, and then all you're going to do is you're going to use these steps to graph one full period of the function. All right, then you're going to add additional cycles. We'll do that to the left or right as needed. Okay. Let's do it. Let's jump right in. I promise you it's not going to be that bad. All right, and you can see here what exactly is going on here, how this is going to be solved, okay? All right, so let's sketch two cycles or two periods. Of this graph. Y is equal to 2 times tangent of x/4. Okay. The most important thing to do here, okay? And you're going to notice I'm not going to do it as I had done previously. Like when we were doing sine and cosine, I set it up, a table of values. I'm not going to do that, okay? Here's what you're going to do. First thing you're going to do is you're going to find two consecutive asymptotes. All right. So look, you're going to have this inequality right here. Okay, so -π/2, and then whatever you have in here, which is just x/4. And then it has to be less than π/2. Okay, so how would you solve this? Okay, if you just want to get x by itself, what you're going to do is you're going to multiply everything by 4. Okay? So look what happens. 4 divided by 2, so I have negative 2 pi is less than the 4's cancel, less than x, and then here 4 divided by 2, which is less than 2 pi. Okay, so this is what I mean here. This right here and this right here are my vertical asymptotes. Okay, so my first vertical asymptote is x is equal to negative 2 pi, and my second vertical asymptote is x is equal to 2 pi. All right, so at this point I'm going to hop over to the next slide, and I'll come back as needed, okay? So sketch 2 periods of this y is equal to 2 times tangent of x over 4. All right, so look, here's what we did. First vertical asymptote occurs at negative 2 pi, and then the second one is at 2 pi. So here's 0. This will be negative pi. This will be negative 2 pi. Here's pi. Here's 2 pi. I'm going to draw these vertical asymptotes. Now look, I'm going to want 2 periods. So the distance from negative 2 pi to 2 pi is 4 pi. And like you can, if you wanted to find the period here, well, the period it's just pi divided by b. Okay? And my b here is 1/4. So it's pi divided by 1/4, which is 4 pi, which is what you're seeing here. So then I'm going to put I'm going to go 3 pi, 4 pi, 5 pi, and then 6 pi. Okay? So look, here's what's going to happen. You'll see. All right, the first thing after you do, you find the intercepts. The point in the middle, so what falls between negative 2 pi and pi is 0. That's where the x-intercept occurs. Then 1/4 of the way, look at how nicely this was set up. It's negative pi. So that ends up being negative a. So that would be negative 2. So it would be down here. And then 3/4 of the way, well, if this is half, that has to be 3/4. So that has to be the value a, which is 2. And then look. You can just sketch the first period. And then look, the graph's going to repeat itself. So this intercept here, or excuse me, this asymptote, not intercept. This asymptote is going to happen at 6 pi here. What falls right in the midpoint between 2 pi and 6 pi is 4 pi. And then 3 pi here is going to be negative 2. And 5 pi here will be positive 2. And here's the second iteration of it. Like that. Yeah, maybe I can do better. And that's it. That's how you graph it. Do you see? Once you figure out the method here, right? It's not as laborious as setting up the table of values and working through that. It's just like boom, 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 boom. All right. Well, let's practice. Let's keep practicing, right? Let's do 2 other ones. Let's do something that involves a phase shift here. All right, so again, we're going to sketch 2 periods. Okay. Of this, we'll look at y is equal to tangent, and then of x minus pi. Okay, the key here is again, just like you saw, asymptotes. Find the asymptotes, okay? Okay, so you start with negative pi over 2 is less than, now just take everything that's in here, which is just x minus pi, less than pi over 2. So then to get x by itself, you're just going to add a pi to each part here. All right, negative pi over 2 plus pi over 2 is just pi over 2. Pi cancels, less than x, and x is less than pi over 2 plus another pi gets me 3 pi over 2. Okay, so here's what's going on. My two asymptotes are x is equal to pi over 2, and this other one is x is equal to 3 pi over 2. And look, because there's no value in front of the x, the period here, it's still pi divided by b, but in this case it's just pi divided by 1, which is why it's just still pi. All right, it gets a little tricky how you label the axis, okay? So I'm gonna teach you a little trick using the unit circle that will really, really help you here, okay? So we gotta set this up, all right? So asymptotes. All right, so sketch two periods of y is equal to tangent of x minus pi. Okay, so the first one is going to be at negative pi over 2. Okay, then I'm going to need the midpoint, and then it's going to be over at, I'm sorry, I wrote negative pi over 2. It was just pi over 2. Sorry. I don't know why I said negative pi over 2. 3 pi over 2. All right, so suppose you're like, well, all right, I need to find the midpoint, and then I need to find a quarter and 3/4. All right, let me just show you how to do this with the unit circle, okay? So between pi over 2 and 3 pi over 2. So you're just going to go back and look at your unit circle, okay? You're going to go pi over 2 and 3 pi over 2. Well, what is the value that falls in the middle of that half circle? Look, it's pi, okay? So that means this midpoint here is pi. Well, how do I find this midpoint between pi over 2 and pi? Just go back to the unit circle. What falls between pi over 2 and pi? It's 3 pi over 4. And then what falls between pi and 3 pi over 2 right in the middle is 5 pi over 4. So you can the unit circle here can help you find the values on the x-axis for these simple ones. And then look, midpoint is 0. 5 pi over 4 is 1 because the value of 1 is in front. Here is negative 1. And boom, you got it. So now you just need to repeat it, okay? So everything, happens every pi because that's the period, right? So, to get the next asymptote here, right? So you're going to add pi to this. It's going to be all the way out at 5 pi over 2. What falls in the middle here then, add a pi to it, you get 2 pi. And then look, 3 pi over 4 plus a pi gets me 7 pi over 4. I'm adding pi because that's the period. 5 pi over 4 plus pi gets me 9 pi over 4. And it's the same thing. -1, 0, 1, and then just butt up against the asymptotes. Like that. Okay. Let's do one last one. All right, I'll throw a lot at you here, and we'll see how we do. Okay. So I'll throw in a phase shift, and we'll mess with the period like we did here, the whole deal. Okay. Let's sketch 2 periods of, let's look at this one. Y is equal to 3 times tangent of 1/2 x plus pi. All right. What's the key? The key, as I said, and actually, you know what you might even do before I do that. I mean, obviously the key is the asymptotes, but you might even want to just pause the lecture, right, and just give this a shot. See if you could do it, and then unpause the lecture. So I'll give you 5 seconds to see if you want to pause the lecture and try this, and then come back and watch me do it. So take I highly encourage you to try it. So I'll be quiet for 5 seconds. I'll give you a chance to pause, and then I'll show you how to solve it. All right. Well, hopefully you did try. But if not, if you just want to watch, here's how we do this. Okay. So you're gonna have to find 2 consecutive asymptotes. Okay, so you're just going to take what's inside the tangent function, like this. So you want to get x by itself here. So the first thing you're going to do is you're going to subtract pi. Minus pi over 2 minus another pi gets me minus 3 pi over 2. Pi and minus pi go away. And pi over 2 minus pi, what does that get me? That gets me minus pi over 2. And then look, you multiply everything by 2, okay? And you end up just getting minus 3 pi is less than x is less than minus pi. All right? So what's going on here is the first 2 asymptotes are x is equal to minus 3 pi and x is equal to minus pi. And look, the period now, because I have this 1/2 here, it's just pi divided by b, so it's pi divided by 1/2. So my period now for this function is 2 pi because I'm changing it with this number in front here. And look, you can see that, right? That's the distance from minus 3 pi to minus pi. All right, let's sketch it. Let's sketch 2 periods of this. So we're going to go from negative 3 pi to negative pi is going to be our first 2 asymptotes. So we're sketching 2 periods of y is equal to 3 times tangent of 1/2 x plus pi. Got a nice big graph here. All right, so look how I do this, right? So I'm going to start over here at negative 3 pi. And look, I'm going to go all the way to negative pi, okay? Well, what falls in the middle of negative pi? Well, that's negative 2 pi. Okay, then here's 0. And then, look, I'm going to do the same things, okay? Then I'm going to put pi, and then I'm going to put 2 pi, and then I'm going to put 3 pi. And I'm sorry, let's actually sketch, I'm going to take this back. Let's sketch 3 periods. This will be fun. Even though I told you to sketch 2, I'm going to sketch 3, and you'll see. Sorry about that. We'll make it even more fun. I'm going to be able to fit 3 periods in here. This is why I'm doing that. Okay, so my first asymptote is negative 3 pi and then negative pi. Right? Okay, so this is why I did that. What falls in the middle here? Boom, negative 2 pi. So that's going to be 0. My a is 3. So I'm going to have to go all the way up to 3 when I find these points here, and all the way down to negative 3. All right, so what falls between negative 3 pi and negative 2 pi? Well, that would be negative 2.5 pi, which is 5 pi over 2. So that's down to negative 3. And then what falls between negative 2 pi and negative pi? Well, that would be negative 1.5 pi, or negative 3 pi over 2. All right, and that's going to go all the way up to 3. So look, boom. That's my first iteration. So I want to do 3 periods. Well, look, the period that this is going to repeat itself is every 2 pi. So what that means is there's going to be a vertical asymptote every 2 pi. So 1 pi and then another pi, and then another pi, another 2 pi, excuse me. So look, you can see here, midpoint is going to be at 0. This is going to be negative pi over 2, and this is going to be pi over 2, because those are the midpoints there. And then you can see how quickly it falls. Negative 3, 3. Like this. And then between pi and 2 pi is 3 pi over 2. And then 5 pi over 2. You can, once you figure out the pattern here, it just, falls so quickly into place. All right, class, I hope these lectures helped, right? And you're gonna, obviously you're gonna get a chance to practice this. And the more you practice, okay, the easier and easier it'll get, and the more quickly you'll recognize these patterns. And as always, if you need anything, I'm here to help.